So definition. We had earlier seen that the two graphs, suppose G with vertex set V and edge set E, and suppose the graph G dash with vertex set V dash and the edge set E dash are edge isomorphic if there exists as a bijection. There exists a bijection. Suppose neta from neta is neta nahi likhenge, hum likhenge psi. If there is a bijection psi from the edge set of E, edge set of G into the edge set of E dash, G dash, which preserves edge adjacency, edge adjacency and edge non-adjacency. Which preserves the edge adjacency and edge non-adjacency. So that is the edges E and F have a vertex in common in E, have a vertex in common in G, if and only if psi of E and psi of F have a vertex in common in G dash. Have a vertex in common in G dash. Okay. Now an edge isomorphism. An edge isomorphism of a graph into itself is called an edge automorphism. Is called an edge automorphism. And the set of all edge automorphisms of a graph G of a graph G is known as the edge automorphism group of G. Edge automorphism group. Edge automorphism group of G, and this is denoted by gamma dash of G. Okay, so gamma 0 of G is the vertex automorphism group, and gamma dash of G is the edge automorphism group. And we had earlier seen that gamma 1 of G is the edge automorphism group, which is induced by the vertex automorphism group. Now, actually, there are certain situations where the edge automorphism group and the induced vertex automorphism and the induced edge automorphism group, which was induced by the vertex automorphism group, for some graphs, these two edge automorphism groups are different. That means there are some graphs where gamma 1 of G is not equal to gamma dash of G. And this happens because there are certain edge automorphisms which cannot be induced by any vertex automorphisms. In vertex automorphisms, we have defined the vertex automorphism as a bijection on the vertex set, which defines an automorphism on that graph. Now, an edge automorphism is it also preserves the adjacencies and the non-adjacencies, and it is happening if and only we have this kind of a situation that if E and F have an edge in common, have a vertex in common, then psi of E and psi of F should also have a vertex in common. Now we will take up certain examples where we will define some edge automorphism, and then we can clearly see that those edge automorphism would not be possible to be induced, to be obtained from an induced vertex automorphism. So there are certain these nice things. So let's consider an example of a graph. Now, in fact, you can clearly construct the edge automorphism group of a graph, but we will here construct certain edge automorphisms on these particular kinds of graphs, where we have this edge automorphism, which we can see then cannot be induced by any vertex automorphism. So now let's call these vertices as V1, V2, V3, and V4. And let's name these edges as, suppose A, this A, B, C, and D. Then we can define an edge automorphism psi. And this psi can be defined as which sends A into D. The edge A is mapped into the edge D. And then the edge B is mapped into edge C. हमें सिर्फ edges को map करना है. Now here edge A and edge D do not have a vertex in common. तो edge A के साथ जो vertices है, it is incident with V1 and V2, और जो edge D है, ये इन दोनों vertices के साथ adjacent नहीं है. So therefore edge A can be mapped into the edge D. Now B and C, they have this vertex in common. Now B is incident with this edge, जो इसकी image है under this psi, it is C. तो C के साथ भी यही edge, यही vertex incident है. So therefore B and its image, C and its image. So under this mapping, we have actually this kind of an automorphism. Sigma of A is equal to D. Sigma of D is equal to A. So therefore now look at these two edges A and D. जो यहाँ पे A और D है, they do not have anything in common. Now psi of A is D and psi of D is A, they also do not have anything in common. Now look at this B and C. We have psi of B is equal to C and psi of C is equal to B. Now look at this B and C. Whatever they have common, that is common between B, C and B also. ठीक है, जो B और C के between common है, जो B और C के between जो भी relations है, they are also actually preserved in the relations among C and B. So B is related to C or C is related to B, it is one and the same thing. So therefore this kind of an automorphism is an edge automorphism on this graph. But now this cannot be induced by any vertex automorphism. तो अगर हम यहाँ पे vertex automorphisms define करेंगे, this vertex has to remain fixed under any vertex automorphism. तो ये vertex कभी यहाँ पे नहीं आ सकता है, ना ही यहाँ पे आ सकता है. So therefore this under a vertex automorphism, this edge can never be mapped into D. And now again, this is a vertex of degree 3. जो यहाँ पे ये वाला vertex है V2, it's a vertex of degree 3, so it can never be mapped into any other vertex. So therefore V1 has to be fixed, V2 is always fixed under any vertex automorphism on this graph. So therefore this edge A will always be fixed under any vertex automorphism. Then the induced जो edge automorphism होगा, that induced edge automorphism is always also fix A. Now look at these two vertices. Now these two vertices can be swapped among themselves. Then the edge B can go into the edge C by an induced edge automorphism, but this thing cannot happen. A can never be mapped into D. ठीक है. So therefore we have this psi. It is an edge automorphism which is not induced by any vertex automorphism. Now similarly, let's construct one more example. Let's construct K4 minus E. These are actually certain special kinds of graphs where we can define such edge automorphisms which cannot be induced by the vertex automorphisms. Now consider this graph V1, V2, V3, V4. And let's name the edges as A, B, C, D, E. Now we will define a vertex edge automorphism psi, which is defined as which sends A into B, B into C, C into D. Not actually D, A, B, C, E. And then D remains fixed. तो हमने यहाँ पे मैप किया A को B के साथ, B को C के साथ, C को E के साथ, and E को A के साथ. So therefore under this automorphism, we have psi of A is equal to B. So actually we can write it like this. ये हम permutation इस तरह से भी लिख सकते हैं. This A, B, C, E, D. Now this A, B, then C, E, and A, then D. ठीक है. Now A is mapped into B. Okay, so now actually you can see that this cannot be obtained by any vertex automorphism. जो यहाँ पे vertex automorphisms होंगे इस graph पे, this V can be mapped into V1 can be mapped into V3. But that vertex automorphism can do one thing. It can map A into B and it will map E into C. तो जो यहाँ पे ये vertex automorphism होगा when we map V1 into V3 and keep these two vertices fixed, V2 and V4. Then A will be mapped into B and E will be mapped into C. तो इस तरह का automorphism नहीं मिलेगा हमें edge automorphism. तो इसी तरह से इसका हम जानते हैं जो इसका जो automorphism group है that's isomorphic to Z2 cross Z2. तो एक तो वो vertex automorphism होगा. Next is if we swap these two vertices V2 and V3, तो उस केस में क्या आ जाएगा edge automorphism? This B will be mapped into C and A will be mapped into E. So again, this is not that kind of an edge automorphism. This and this is different. Now the last vertex automorphism, non-trivial vertex automorphism that we can define on this graph is V1 goes into V3 and V2 goes into V4. तो उस केस में जो edge automorphism होगा वो क्लियरली ये नहीं होगा. ठीक है, वो भी अगर आप देखना चाहेंगे वो किसके बराबर होगा. सो लेट्स कंस्ट्रक्ट दिस ग्राफ. वो इनफैक्ट हमने कल भी किया था. तो इस केस में क्या होगा? Now suppose V1 is mapped into V3. So we have V1 here, this V3, V2 is mapped into V4. Now edge between V1 and V2 is A. V2 and V3, that is B. V3 and V4, that is C. And V4 and V1, that is E, and D remains fixed. So now what is the edge automorphism? While A is mapped with, A यहाँ पे है, now A is mapped into C, क्योंकि यहाँ पे अब C है, and C is mapped into A. तो इस तरह का automorphism बन गया. Now B यहाँ पे है और यहाँ पे इसमें E है, so B is mapped into E, and E it is mapped into B, and D remains fixed. So again this and this are different. ठीक है. So therefore none of the vertex automorphisms defined induce this kind of an edge automorphism on this K4 minus E. So therefore this is also an edge automorphism which is not induced by a vertex automorphism. तो इसी तरह से नाउ अभी कितना टाइम है हमारे पास? आई थिंक 16 ऑन हम अभी हमें सिर्फ 16 मिनट्स हो गए इस दूसरी मीटिंग, ठीक है? हाँ ठीक है, सो आई वी कैन एक्चुअली कंप्लीट इट, आज हम इसको पूरा करें. Now let's define the next topic, graphs with a given group. चलिए वहाँ पे हम एक और एग्जांपल भी लेते हैं. चलो वो हम बाद में करेंगे, ठीक है? वो मैं आपको नोट्स में लिख के भेजूंगा. So let's try to finish it. Graphs with a given group. अभी तक जो हमने किया, we had started with a graph and then constructed a group. But now we will start with a group and then construct a graph and see what happens. So this is definition of a Cayley graph. So let's see how we define a graph from a given group. Let gamma be a group. Usually यहाँ पे जो algebra graph theory में gamma is denotes a group. Let gamma be a given group. Be a given group, and let tilde be a subset of gamma not containing the identity. Not containing the identity. Then the Cayley diagram. This was defined by Cayley, that is why it is known as a Cayley diagram. Then the Cayley diagram of gamma with respect to tilde is defined to have its vertex set as gamma. That means all the elements of the group are considered as the vertices of this Cayley diagram, and the edge set is suppose E of gamma, which is defined as some gamma and then gamma h, such that h belongs to gamma. So असल में h, first we take the vertex set. The vertex set vertices of this graph are all the vertices of the given group gamma, and there is an edge from some gamma into gamma h, and gamma h is also an element of gamma, because this is gamma h is actually the composition of two elements of gamma. Now this h is in gamma and gamma is, so this is the, while this h is in tilde, ये हमने यहाँ पे गलत लिखा, this h is in tilde, so h is in tilde. Now h is in tilde and tilde is a subset of gamma, so therefore this gamma h, since this gamma is a group, so therefore this gamma h will also be an element of gamma. तो इस तरह से अगर हमारे पास कोई भी एलिमेंट गामा होगा, it will be mapped into, it will be joined by a directed arc from gamma into gamma h, while h belongs to tilde. ठीक, तो इस तरह से edges यहाँ पे define किए जाते हैं. So now let's take an example. Let पहले हम एक आसान सा ग्रुप लेते हैं. Let gamma is equal to a cyclic group Z4, and let us choose tilde is equal to we have to choose this tilde spatially. We don't have to choose tilde containing the identity. हमें identity को बाहर रखना है. Now let's choose 1 and 2. हम कोई भी सबसेट ले सकते हैं. Let us choose 1 and 2. ठीक है. So then vertex set of this gamma, then vertex set is, इसको पहले हम नोटेशन यहाँ पे इंट्रोड्यूस करेंगे. This is denoted by D, which is defined as D with vertex set gamma and the edge set, not actually the edge set, this is gamma, D gamma tilde digraph of the group G of the group gamma with respect to the chosen subset tilde. So therefore here we write the vertex set of D, Z4 and tilde. Its vertex set is the elements of Z4. So vertex set are 0, 1, 2, 3. Now we have to define the edges. First we will make the calculations and then we will construct the graph. Now the edges are defined as, we have to compute all these ordered pairs gamma and gamma edge, where gamma belongs to the capital gamma, it is an element of a group, and this edge is an element of this chosen subset tilde. So हम one by one choose करेंगे. Now let's again repeat it here. Now here gamma is equal to Z4 and it contains these elements 0, 1, 2, 3. And then tilde, this contains these two elements 1 and 2. Now we have to define the vertices, and the vertex edges are defined as then the edge set of D. It is defined as gamma, then gamma edge, such that H belongs to tilde. तो हमें अभी सारे ordered pairs ये calculate करने होंगे. So choose this gamma is equal to 0. If gamma is equal to 0, then we have 0 plus 1 and 0 plus 2. तो हमें अब गामा एज देखना है. व्हाट इज दिस गामा एज? तो ये 0 इन दो एलिमेंट्स के साथ मैप होगा. 0 दिस गामा विल बी मैप्ड विद gamma plus 1 and gamma plus 2. So it is 0 plus 1 and 0 plus 2. Now this is equal to 1 and this is equal to 2. Now if gamma is equal to 1, then we have to calculate then this gamma plus h. This is equal to 1 plus 1 and 1 plus 2. Now 1 plus 1 is equal to 2 and 1 plus 2 is equal to 3. Now if gamma is equal to 2, then what about gamma plus h? This is equal to 2 plus 1 and 2 plus 2. So this is equal to 3 and this is equal to 0. And the last one is gamma is equal to,
gamma h लिखा ना,
ये है ना ग्रुप ऑपरेशन. यहाँ पे एडिशन, वहां पे कहीं पे मल्टीप्लिकेशन, कहीं पे कोई भी ग्रुप ऑपरेशन होगा. ठीक है.
yes sir.
ये मल्टीप्लिकेशन नहीं है, it depends on the group operation. Okay, now gamma is equal to 3, then gamma plus h. This is equal to 3 plus 1, which is equal to 0, and 3 plus 2, which is equal to 1. ठीक है. Now the vertex set of this the diagram D, it contains these 4 vertices 0, 1, 2, and 3. And the edges are defined in this way. Now the vertex 0, it is adjacent with 1 and it's also adjacent with 2. So this is adjacent with 1 and this is also adjacent with 2. And there is a directed edge from 0 into 1, 0 into 2. So there is an edge from 0 into 1, 0 into 2, because it's a diagram. Now edges divided from 1 or 1 goes to 2 and 1 goes to 3. Now 1 is connected with 2, and also 1 is connected with 3. Now 2. 2 is connected with 3 and 0. 2 is connected with 3 and 2 is connected with 0. Now 3 is connected with 0. ये क्या किया मैंने? 2 is connected with 0. मैंने यहाँ पे गलत लिख दिया. This is not here. 2 is connected with 3 and 2 is connected with 0 also. तो हम यहाँ से एक और एज बना सकते हैं. Now 3 is connected with 0 and 3 is connected with 1. So this is the graph. So this is the Cayley diagram D with underlying group, given group Z4, and the subset chosen is 1, 2. Okay. Now can we take the next example or do I have to repeat it? Okay, ठीक है. Example number 2. पहले एग्जांपल में मैंने खुद ग्रुप चूज किया था. अब यहाँ पे आप ग्रुप चूज कीजिए. Let the group gamma is equal. बताइए कोई ग्रुप.
S3.
चलिए ठीक है, S3. और इसका टिल्डा चूज करेंगे हम. कुछ एलिमेंट्स बताइए, 2-3 आप बता सकते हैं विदाउट आइडेंटिटी.
1, 2, 2, 3. Transpositions.
ये ठीक है. 1, 2. चलो 1, 3, 2 लिखते हैं. ठीक है. Then this diagram will have 6 vertices, and now let's see how the edges are defined. So first choose let gamma is equal to, तो पहले हम रिपीट करेंगे वो definition. So let's recall the definition. The edge sets of D are defined as it is gamma, then gamma H such that H belongs to tilde. Now first let's choose gamma is equal identity. तो फिर हमें define करना होगा this gamma 1, 2, and we also have to find out gamma 1, 3, 2. Now this will clearly be equal to 1, 2, and this is equal to 1, 3, 2. ठीक है. तो यहाँ पे ज्यादा कुछ नहीं करना था. Now second one is, now choose gamma is equal to some this 1, 2. Then we have to evaluate this gamma 1, 2 and gamma 1, 3, 2. But now here gamma is equal to 1, 2. So this is 1, 2 into 1, 2. Now here this is 1, 2 into 1, 3, 2. Now we know this equal to identity. And what is this equal to? This is equal to 3. Now the third one. Now gamma is equal to 1, 3. Then we have to compute gamma 1, 3 and gamma 1, 3. No, gamma 1, 2. We have to compute gamma 1, 2 and gamma 1, 3, 2. So this is equal to 1, 3 into 1, 2. This is 1, 3 into 1, 3, 2. अब ये किसके बराबर है?
1, 2, 3.
1, 2, 3. और ये किसके बराबर है? I think it is again 1, 2, 3. क्या है यहाँ पे? हाँ, ठीक है. Now the fourth one is choose gamma is equal to 2 3. तो फिर हमें चाहिए gamma 1 2 and gamma 1 3 2. Now this is equal to 2 3 into 2 1, and this is equal to 2 3 into 1 3 2. Now what is this equal to? 2 1 3, और ये किसके बराबर है? I think it is 1 2 now. ठीक है. Now the fifth one is gamma is equal to now gamma is equal to 1 2 3. Then gamma of 1 2, and what about gamma of 1 3 2? Now this is 1 2 3 into 1 2, and this is 1 2 3 into 1 2. Now what is 1 2 3 into 1 2? I think this is 2
1
3.
3.
1 3 or 2 3? 1 goes to 2 here, and okay, 1 3 1 3. So this is 1 3. Now यहाँ पे क्या लिखा? This 1 3 2. ठीक है, this is what identity. Now the sixth one, if gamma is equal to 1 3 2, then we have to compute gamma 1 2, and we have to compute gamma 1 3 2. Now gamma is equal to 1 3 2 1 2, and here it is 1 3 2 1 3 2. Now what is this equal to?
2 3.
Okay, this is 2 3, and this is 1 2 3. ठीक है. ठीक है यहाँ तक?
Yes, sir.
Yes, sir.
Okay, now let's draw a graph then. So graph हम यहाँ पे
अगर हम टिल्डा में आइडेंटिटी लेंगे ना, वहाँ पे सेल्फ लूप बनेगा फॉर एग्जांपल.
अगर हम टिल्डा
अगर
में
ये-
लेंगे आइडेंटिटी, वहाँ पे हर एक वर्टेक्स पे सेल्फ लो बन जाएगा. अगर हम यहाँ पे लेंगे सपोज आइडेंटिटी, तो हम देखेंगे यहाँ पे क्या होगा. सपोज इफ वी चूज आइडेंटिटी, तो यहाँ पे हमें कैलकुलेट कर क्या करना पड़ेगा? गामा इनटू आइडेंटिटी. सो दिस इज इक्वल टू आइडेंटिटी इनटू आइडेंटिटी इज इक्वल टू आइडेंटिटी. ठीक है. तो आइडेंटिटी पे सेल्फ लूप, देन if we choose here 1 2, तो 1 2 identity will be equal to 1 2, तो इससे 1 2 पे भी सेल्फ लो बन जाएगा. ठीक है. अब
Yes, sir.
तो इसलिए हम आइडेंटिटी इसीलिए वहां पे अवॉइड करते हैं. सो नाउ लेट्स ट्राई टू कंस्ट्रक्ट अ ग्राफ. तो इसमें अब 6 वर्टिसेस होंगे. आप ग्राफ बना सकते हैं खुद.
Yes, sir.
अच्छा, तो यहाँ पे बस आपको लिखना है आइडेंटिटी में इज मैप्ड इनटू 1 2 एंड 1 3 2. दिस 1 2 इट इज टू बी मैप्ड इनटू आइडेंटिटी एंड 2 3. 1 3 को मैप करना है 1 2 3 और 2 3 के साथ इसी तरह से, लेकिन डायरेक्टेड एज. चलो ठीक है. आप इस
सर ये साइकिल बनेगा ना, मगर क्योंकि हर एक वर्टिसेस की डिग्री 2 ही है ना.
नहीं, 2 कहाँ है डिग्री वर्टिसेस की?
सर ये 2 3 है ना, 2 ही से फिर कनेक्ट. ठीक.
या बना लीजिए ग्राफ, तो वहां पे वो बन जाएगा. फिर साइकिल नहीं बनेगा ये. ठीक है, so I think we should
ठीक
now
है sir.
stop here.